Good day, folks. Welcome to Bright Mind Academy, where we bring brilliance to every lesson. In today's video, you're gonna do multiple choice question based on work, energy, and power. Now, the first question under multiple choice questions, it says a hot air balloon is moving vertically downwards at a constant velocity. Assume that the mass of the hot air balloon remains constant. Now, another statement says, or rather, a question says, which says now to us which of the following physical quantity associated with the hot air balloon changes during the motion. Very important. Changes during the hot air balloon. Now let's see the information that we are given. We have a hot air balloon. Hot air balloon there. I'm not a drawist or an artist. So here's our hot air balloon moving downwards at a what? Constant velocity. Meaning that our velocity does not change. Our velocity does not change, meaning if it was 5 meters per second here, 5 meters per second there until it reaches the ground. All right. Now, if our constant velocity does not change, it means everything that has velocity does not change. Any formula that has velocity does not change. All right. Now, another thing happen is that the mass of the hot air balloon remains constant. Assume that the mass does not decrease or increase. Again, all right. Which one of the physical quantities associated with the hot air balloon changes during the motion? Let's see. Weight. Weight. Now, what is weight? Weight is mg. Again, let's do this. Let's consider A. Option A. Weight, it is what? Mg. Now, we are told that our mass is constant. Then our gravitational acceleration, it is constant. Leon, it is 9.8. So it's going to be these values until it reaches the ground. So, since our mass does not change as well as our gravitational acceleration does not change, it means that our weight will not change in this case thereof. It means it won't change. So this one, it is incorrect. B, momentum. What is the formula for momentum? Momentum says now to us P, it is equal to mv. Now P, if it is equal to mv, if our mass does not change and our velocity is constant, it means our P will not change. Therefore, P is not the answer we are looking for. Kinetic energy. Formula for kinetic energy, it is half mv squared. Mass does not change, velocity does not change. It means now kinetic energy is not the answer we are looking for because it will not change. Now, what about potential energy? Potential energy, it is mgh. Now, m is constant, g is constant. What about h? If it is moving downwards, let's say height here, it is 5 meters. But as it goes down, our height changes. Our height changes now. So it means now this value, mgh, our potential energy will do what? Will change. So it means our answer for this multiple choice question, it is number D for 2 marks. It is a matter of understanding your concept there. Now let's move to our second part of the multiple choice. You say 1.4, an object of mass m is accelerated from a velocity v to a velocity 2v as shown in the diagram. We can see what is the net work done on an object. Remember, net work done from the definition. It says W net, it is equal to change in K, where our change in K, it is our what? Half mv squared final minus half mv squared initial. If I were to take out half m as my common factor, I'm going to have vf squared minus vi squared. Now let's substitute and see the work. Now we are told that, all right, this is constant. We are told that a final velocity, it is how much? 2v. This is our final velocity. This is our initial velocity. Final velocity is going to be 2v squared minus what? V squared. This will give us what? We'll say half m. What is a 2v squared? 2v squared is going to be 4v squared minus 4v squared minus v squared. I know it's the same as saying 1 squared, which is 1, which is v squared. We all agree that if we do our mathematics correctly, our answer here should be half m. Then our velocity 4 minus this one, it is a 3v squared. But now we can multiply this half and this 3. It's going to give us 3 divided by 2 mv squared. Where is that option? That option, it is what? Number C. So it means number C, it is the correct answer thereof. Or then 1.5, which is number 3. A box moves on a horizontal surface. The diagram below shows all the forces acting on the box. Now, if I were to draw a free, all right, let's hear the question. Which one of the following combination of the force do work on the box? Remember one thing: the ones that are doing work should be the parallel components. We know that perpendicular components do no work. Do no work. Perpendicular components do no work. So now let's draw our free body diagram. Remember, this is more or less a force diagram, but let's draw a free body diagram with components of Q. Now it's gonna be R. Oh my goodness. Sorry. It's gonna be R. Sorry for the tidiness. R, S, P, Q. It is acting at this angle again. So we know if we were to break a P into its components, it's gonna be what? Let me just do this. Here is Q, rather Q. So its components is gonna be what? QX as well as QY. Now we know that forces that are doing work are these ones, the ones that are acting parallel, which are what? S and Q. Again, S and Q are the only ones that are doing work. We know in this case it is a QX, but it is a component of what? Of Q. So these ones, P and R, if we were to talk about P and R, if we wanted to eliminate some options, P and R do not do any work. So A is out. A is out because there is P and R. It is out. B, Q, and S, there is no P and R. It might be an answer. C, there is R. R and does not do any work. So we cancel out R. D has P. It also has R. We cancel out. So the correct answer should be B. As I've stated, S and QS, QX in this case, are the ones that are doing what? Work. So S and Q are the ones that are doing work on the object. B is the correct answer. 1.5 states that this will be our number 4. 1.5 states that a stone of mass m is dropped from a height above the ground. Ignore the effect of air friction, very important. Which one of the following combination in the table below correctly represents the what? Let me use a different highlight. Represents the what? The kinetic energy and the total mechanical energy of the stone. Of the stone. The instance the stone has fallen the distance of 1.4. Now, let's do this. Let's say we have our height there. This is of height h. Then we have our stone being what? Being dropped. That stone is dropped. So if something is dropped from vertical projectile motion, it has an initial velocity of 0 meters per second. Again, so this is what I normally say. If it is dropped here, with regards to this position, here, we have mgh. It is there because we have rather, let me not say yeah, it is mgh. We have mgh, which is our potential energy. Why? Because it is at a certain height. Okay, yes, but do we have ek? No, we do not have ek. We do not have what? Ek. Okay, so if I were to use mechanical energy at this point, it's gonna be what? It's gonna be only what? Only mgh plus what? Plus zero. Why? Because my kinetic energy here, it is how much? It is zero. Ek, it is zero. This is very important. Please take note of this. Please, 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 please hear me. As I move down from this point to this point, my height is decreasing. My height is decreasing, but my velocity, it is increasing. I repeat, as I move from this point, point A, to this point, point B, my height is decreasing from h, from 1h to maybe 0.9h, 0.8h, which is decreasing. Now, what is happening to my velocity? My velocity is increasing because now it is under the influence of gravitational acceleration. So my velocity increases. So it means now at this point I have mg and some portion of, let's say it is at a distance of if this is 4 over 4 h, 3 over 4 h, somewhere somehow there, let me bring back my, somewhere somehow there, it is 2 over 3 h, then yes, then maybe here it is 1 over 4 h, not 3, 4h, then here it is 0 divided by 4h, which is 0h. Now we see as we go down, our height is decreasing. But what happens to our velocity? Our velocity in this case, our velocity might move from 0, 2 meters, 4 meters. This is an example. 6 meters, and eventually let's say 8 meters per second. Now, what I'm trying to explain here is this part. Please hear it. Please make sure you understand. If here I'm having mgh and it is equal to mgh, yes, I'm having, let me say ep, it is equal to ep, it is equal to mgh, and ek, it is equal to 0. As I go down, my ep is decreasing. But what happens to my ek? It is decreasing. So it means, since while our system is conserved here, it means some of the energy, this is very important, please. Some of the energy that is lost by the potential energy, it is transferred to the kinetic energy. As it loses further energy, ek, it is gaining that energy. ep losing further energy. ek, it is doing what? It is doing gaining that energy. So it means whatever the energy that is lost by our ep, it will be gained by our kinetic energy. I hope that's clear. Let me erase this and try to answer the questions that we were asked. I can't even remember what the question was saying, but let's try to answer the question. Now, here's our question. Our question was saying now, correctly represent, which one of the following combination or in the table below correctly represents the kinetic energy and the total mechanical energy of the stone at the instant has fallen, at the instant the stone has fallen the distance of 1 over h. Let's say this is full h again. So we want an instant that it has fallen this distance here. Now it moved from this portion and projected downwards to this portion, which has a height of 1 divided by 4 of the original height, which is 25% of the height. Now let's talk. I said mechanical energy of the system is conserved. Why? Because there is no friction. There is no any other external forces. So it means now our remember when I started at the top, I said my mechanical energy is gonna be EP plus EK. But now EP it is what mgh. My kinetic energy it is 0. So it means even when I move downwards, whatever, even if my thing is gonna be at the bottom, my EP is gonna be 0, but my EK is gonna be half mv squared. But remember, this half mv squared is from what? From this mgh. Why? Because I said as we go down, mgh transfers its energy to kinetic energy. So it means this is the same as saying this is the mgh. So it means our total kinetic energy cannot be half 1 over 4 mgh, cannot be 3 over 4 mgh, but can be mgh. Why? Because it is conserved, our mechanical energy. Again, what happens to our kinetic energy? Now, if it is in this case, what is our all right? As I go down, my EP is decreasing. Again, my EP in this instance here is gonna be 1 over 4 mgh. We agree. At this point here, my EP is gonna be equal to 1 over 4 mgh. But what will be my EK? My EK will be the same. Why am I saying my EK will be the same? Because now, whatever that has been lost, but sorry, uh, by that, or rather, let me do this. I think there is a mistake that I'm doing here. If I'm doing a mistake here, if now our object has fallen a distance of 1 over 4 h, it means the remainder of the distance to be traveled. The remainder of the distance to be traveled, it is 3 over 4 h. So for now, it has lost. Hence, I'm putting a minus here. It has lost what? It has lost 1 over 4 h. That height again. It has lost one fourth or a quarter of it, a first quarter of it. But we know that first quarter of it is gonna be gained by what? By our kinetic energy. Loss in EP, it is a gain in EK. So EK is gonna gain that 1 over 4 mgh that was lost by our EP. So it makes B under kinetic energy correct, 1 over 4, and this one correct. But we see how D is the most correct. Sorry, D is the most correct answer. I know this is long, but I had to explain this so that you understand. This is very important of you to understand the multiple choice questions. This easy to mark. It is not 2 marks just because it is something that you can just see. You can if you are now good with your theory, and yes, but if you are not good with your theory, it needs you to apply. And this is the application that you have to apply so that you understand. One might be tempted to say the answer was a 3 divided by 4, maybe, I don't know. But yeah, either way, the answer is D. The last question under multiple choice questions, which I can say it is number 5, it states that two forces, each of magnitude 300 newtons, are simultaneously applied to a grate at rest. The grate it is initially at rest, again, as shown in the diagram below. Ignore the effects of friction. All right, there's no friction in this case, there are only forces. Work will be done by the net force on the grate, because the grate will now we will have work done by the net force if 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 our object is not at rest. These conditions tells us There will be work done by the net force. The minute we have net force, it means our velocity, it is not zero, meaning not at rest. If you have our net force, it means our object, it is not at rest. Again, yes, that is the first thing. It is not at rest. Then it means our object should accelerate either in that direction or in that direction, depending on the magnitude, the bigger magnitude between this one and this one. I know someone might say it will be at rest because this is 300, this is 300, but no, remember the work done on this object by this force, it is this one rather, the 300 sine, rather cos of 30. Let me show you with a use of free body diagram. Let's draw a free body diagram for this object. We'll only consider, I'm gonna draw only for the parallel components because they are the ones that are doing work. This is 300 newtons. But when I come here, do you agree with me that what's gonna do work here is this force acting parallel? This one, it is not doing any work. So if this is our triangle, this is gonna be sine, this is gonna be cos. It means I'm gonna have my what? My 300 cosine of 30 according to my triangle. It means here I have 300 cos 30 degrees. Now 300 cos 30 degrees, I do not know how much it is. I do not even have a calculator near me. This is 60, this is 30, this is 1, this is 2, this is square root of 3. Let's see. Cos 30 in this case, it is this and this. So it's gonna be 300 multiplied by cos 30 square root of 3 divided by 2, which is 150 multiplied by square root of 3. Square root of 3, one thing for sure, it is less than 2. Square root of 3, it is less than 2. So it means this value here, because if I were to say 150 multiplied by 2, it's gonna be 300. But if this is less than 2, it means this value should be less than 300. I don't know. You can punch your calculator there. This value here, if I were to write it correctly, it is less than 300. This less than 300 newtons. Now, if this is less than 300 newtons, it means our F net is going to be acting towards the right. This is our F net towards the right. Let me approximate this to what, let me see, maybe 280. Let me just use 280. Actually, I do not have my calculator with me near me, and for the purpose of time, let's just add. Stop assuming. People, when you assume, they take it as it is. So this is gonna be 300 square root of 3 divided by 2, or simplified further, you can say it is 150 root 3. So my F net, it is towards the right. Now let's see our options. Let's eliminate. D cannot be an answer. Remain at rest. This one cannot be an answer. D cannot be an answer. Let's check C. Accelerate towards the right. This one might be an answer. B, accelerate towards the left. That's wrong. Our F net, it is towards the right. Now A, be lifted off the surface. Remember, if this is our surface, our object will never move upwards because there is no work done by the vertical forces or parallel forces. So A, it is incorrect. So it means our correct answer, it is C in this case. You see, multiple choice can seem as something easy, straightforward, but if you do not know your concept, you will never get them correct unless you do a piggy Mabelan that's correct in that particular method of. So yes, thank you very much, folks, for joining me today on multiple choice questions under work, energy, and power theorem. or rather work energy and power topic until we meet again on the next 3 videos that I will record it. Thank you very much. And please, if you like the video, please kindly subscribe and give it a thumbs up. Thank you very much, folks.